All right, guys, today we're going to talk about subtracting real numbers, and really we're going to focus on what happens when you've got positives and negatives together that you are looking at subtracting. So the subtraction rule, the thing that we are going to follow that works for every single problem is this. To subtract one thing from another, B from A, first you add the opposite. And I know we've talked about that this year. We add the opposite of B to A. So here's what it looks like. If you have A minus B, we're not going to think about that as subtraction. We're going to think about that as the same thing as adding the opposite of B. So we don't mess with the first number. The A stays the same. But if we're going to change the subtraction to adding, we can't just put A plus B. That's not the same thing as A minus B. We're going to change this to adding and make this the opposite. The opposite of B is negative B. A plus the opposite of B. Let's try it with actual numbers. 15 minus 7. Now we know, we've learned in the past, 15 minus 7 is just going to be 8, right? But algebraically, it's going to help us to be able to think about this as an addition problem, especially when we're using the commutative property where we can change the order of things. So if we needed that to be addition, we're going to change that. We don't mess with the 15, but in order to change subtraction, we need to add the opposite of 7. What's the opposite of 7? Negative 7. That's why we talked about all these opposites already this chapter. So then we could add it. Is 15 plus negative 7 going to be the same thing as 15 minus 7? What were your adding rules you learned? 15 plus negative 7, you'd actually subtract them in your head anyways, and you would get a positive 8. It's the same thing. So we're going to try doing these difference problems, subtraction problems, changing every subtraction, every one, to adding the opposite. So negative 10 minus 4. You don't mess with the negative 10. That stays. But we're going to change minus 4 to adding the opposite of 4, plus negative 4. Now, a negative plus a negative, we learned, gets more negative. So negative 10 plus negative 4 is negative 14. Try this guy. 13 minus negative 11. This is where it really comes in handy to be able to do this, because 13 minus negative 11 is really hard to picture in your mind. But if you change this to adding the opposite, this becomes 13 plus what? What's the opposite of negative 11? Positive 11. That's much easier to think about. 13 plus 11, that we can do really quickly. That's going to be 24. Much easier to think about than minus a negative 11. All right, so let's take this and let's apply it into some situations where we're plugging in for some variables. So example 2, we're going to evaluate this expression right here, a minus b plus 5.3, when a equals 6.5 and b equals negative 3. So what do we do to evaluate a variable expression? We plug it in, plug it in. We plug in for a and b. So instead of a, I'm going to write 6.5 minus, for now I'm going to keep everything the same, I'm just going to plug in. B was negative 3. So I've got to be careful there that I actually write a negative 3 because that's what B was. But now I have this weird thing minus a negative. Let's get rid of all the subtraction now. In order to change that subtraction to adding, we'd have to add the opposite of negative 3, which is positive 3. So we keep the 6.5, we change this to plus, and the opposite of negative 3 is positive 3. And now we can add these things up. So let's see. If you do all the whole numbers first, 6 plus 3 is 9, 9 plus 5 is 14. And then can you do the tenths? 5 tenths and 3 tenths gives you 8 tenths. There we go, our 14.8. Okay, so let's try this. Let me do one with you, and you'll try one on your own. Negative 4 minus 8, we're going to show changing this to adding the what? Adding the opposite. Negative 4 does not get messed with. That first one stays the same. It's only when I want to change subtraction to adding, I have to change what's after it. What's the opposite of 8? Negative 8. That would be the work that you'd show for me. And now, negative 4 plus a negative 8, negative plus a negative gets more negative. We get down to negative 12. You got it. All right. Try this guy on your own right now. Can you just take a minute and rewrite that? Rewrite it with addition to mean the same thing. I'll give you a second. So you didn't mess with the first one, still 9, but in order to change this to addition, I've got to add the opposite of 18, which is negative 18. And now we're going to add these. Remember our addition rules. One was positive, one was negative. This one was the bigger absolute value, the bigger value there, so we're going to actually subtract it, and it's going to stay negative. If you're at 9 and you're going 18 down, it's going to end up in the negatives. Okay. Let's do a couple where we're plugging in here. Let's get that centered. All right, can we evaluate this when m is 3.2 and t is negative 4? So the first step, plug it in, don't mess with the subtraction yet. So instead of m, 3.2 minus, and now what's t? Negative 4. We get minus this negative 4. If you want, you could put it in parentheses just to separate it. Minus a negative. Then there's plus 2. We didn't change anything yet. All we did was plug in. Now we're going to get rid of subtraction. We're going to think about subtraction as adding the opposite. And what you can do here, guys, is you can just change that subtraction to adding, and what's the opposite of negative 4? Positive 4. You could just do it right there if you want to. So if we add up all these whole numbers, 3 plus 4 is 7, plus 2 is 9, and then the tenths is just a 0.2 left. 9.2 for this guy. Let's plug in for number 4. Instead of m, we put in 3.2 minus 3 minus, what is t? Here's this minus negative 4 again. All we did was plug in. We didn't change the subtraction, but now that we've got all numbers in there, we're going to change all the subtraction to adding the opposite. So I'm going to write it down here one more time. You could just change it right up here if you'd like. Instead of minus 3, plus a negative 3. Instead of minus negative 4, plus a positive 4, the opposite. All right, now we still need to do what's in these parentheses first here. Now 3.2 plus a negative 3, that's a little bit trickier. Okay, if you've got 3.2 and you're going down 3, you're not going to quite get below 0. All right, this is a higher number, higher absolute value, so the answer is going to stay positive. It just brings you down to 0.2. Then we've got plus 4, so 0.2 plus 4, 4.2. There we go. All right, so this is a situation in words here. A hiking trail. A sign at the start of a hiking trail states that you are 320 feet below sea level. What kind of integer would we use for below sea level? Probably a negative, right? At the end of the trail, another sign states you are 880 feet above sea level. Wow, that's a pretty big hike right there. Find the change in elevation. That means how far did you change up and down from below sea level to above sea level. So the change in elevation, we're going to take our highest minus our lowest in this case, and that's going to give us the difference in elevation. So the change in elevation is the elevation at the top of the trail minus the elevation at the bottom, or maybe the end minus the beginning, either way. So the change in elevation, where were we at the end, the top of it when we got up there? 880 above sea level. When we started, what was that very lowest point? We were at 320, but were we at really 320? No, we were at 320 below sea level, so we were at a negative 320. So now, 880 minus a negative, can we get rid of that minus a negative and change it to adding the opposite? We don't mess with the 880. We add, what's the opposite of negative 320? 320. So the opposite of negative 320. And now we can just add those guys together. 800 plus another 300 is going to be 1100, and then 80 and 20 is a whole nother 100. So 1200 feet, right? And that's the change in the elevation. So we hiked 1200 feet up. That's a lot. Does that make sense that it could be more than 880? If you're starting here sea level, you're starting somewhere below sea level, and you're climbing all the way up to 880 above sea level. You got 880 there, plus another 320 from below. Is that what we ended up doing here? Added them up. So it does make sense. All right, let's try a similar question right here, this exercise. In the morning, you woke up and the temperature was -3 degrees. Oh my goodness, hopefully not yet, right? In the afternoon, the temperature was 21 degrees Fahrenheit. What was the change in temperature? Well, guys, the difference is going to be the highest minus the lowest. So 21 was the highest, minus what was the lowest? A -3. How would we do 21 minus -3? How are we going to change that? You don't mess with the first one. We change this to adding the opposite of -3 is just 3. 21 plus 3, 24 degrees. That's how much it changed throughout the day. So there's our answer. All right, so we're going to do a little bit of practice where when you guys see any problem where it is subtraction, you're going to show us changing it to adding the opposite, even if you can do it in your head without showing that. We need to be able to see that you can change any subtraction problem into adding the opposite.